I'm Karen Cito.
Nice to meet you.
Come to my doctoral seminar
great.
right afterwards. Yeah.
Excellent.
Yeah, I see we have a very, very packed full days. We're looking forward to your talk.
Yeah, cool.
Yeah.
Great.
Okay, great.
Okay, do you tend to stay at the podium when you speak, or do you move around?
I tend to stay at the podium.
Okay, stay at the podium. Okay.
You can put this maybe over here on this chair.
Okay.
Okay.
So if you stay within 3 feet of the podium, you'll
Yeah.
be fine.
Okay. With this,
So promise me you're not going to walk away.
I promise you, I'm not going to walk
All
away.
right.
And then this has a little thing.
Yep. We just need to pop the into
yeah,
the
right.
USB port.
And this does it have a laser pointer?
Yes.
This one?
Yep.
Great. Yeah,
And
I
then just
definitely
check
won't walk
to
away.
make sure it advances your slides. Yep. Perfect.
Sweet. Thank you. Is this my water?
Is that water for Emma, or is that water left over from the last section? Melanie.
Okay.
Karen, should we start or linger, or what are we doing? Should I? Right, so I thought. We can get cookies and start. Are you making that? I'll wait for another moment.
Did your daughter's bed get delivered?
It did. It was on my porch when I got home. But they weren't supposed to be there till 4. I was there at 10 to 4.
I was already there.
It was already there.
Yeah.
All right, why don't we go ahead and start settling down. We've got GIS dates, so we're already starting a few minutes late, and I want to give you maximum time today with Emma. Today's speaker is Emma Fuller. She received a PhD in ecology and evolutionary biology from Princeton, working with Simon Levin, which is where I first met Emma, working on a project related to fisheries with Simon. As part of Emma's PhD, she really sort of developed a self-designed curriculum in ecological data science. And I think this is telling. If you Google Emma, the first thing that comes up after the Google Scholar page, which Google promotes, is her GitHub site, which has a lot of her work from fisheries on it. And then I think many of us who knew Emma as a PhD student, despite thinking that she could probably have a pick of tenure track positions, Emma decided to go work for a tech startup called Granular, which is now owned by DuPont, using data and ecology to enhance precision ag for wins for farmers and wins for the environment. She also owns and operates Northbourne Farm, an organic horse and human-powered farm on Vashon Island outside Seattle with her husband. So, despite Emma not being an FES alum, I actually think she's probably living the FES student dream right now. So,
Cool. Thank you. Thanks, everyone. Great. So I'm super excited to be here to talk to you guys all about what I do as a data scientist at Granular. So I'm going to start with an introduction, a little bit about me, why I'm motivated to think about these things, just set the scope a little bit for the talk. talk about what Granular is, why it's useful for farmers, what kind of data science work we do there, and then some of the work that we're doing around sustainability. So some background. So my motivation when I started my PhD at Princeton was how do we balance human well-being and ecological integrity? And in particular, I found fisheries to be a really compelling case study for this, right? So you have a system in which fishermen are this conduit both for ecological dynamics, right? The distribution and abundance of fish really drives behavior, just as economic systems do, right? So demand. Doesn't matter, you can fish it if you can't sell it, or if you can't sell it to a processor. So both supply chains and demand come into play in trying to understand the dynamics of how fishermen impact these systems. Farming is very much the same, right? So you have a farmer who both depends on the quality of the soil or the weather, and is also feeding into these massive commodity chains. So I found these both like very intellectually compelling and ethically motivating because these problems really matter. Agriculture is a super broad term. It could mean anything from rice farming in India to reindeer farming to wheat commodity growing. It could be livestock, can be orchards, can be whatever. So in particular, I want to say that I'm going to be focusing on commodity crops, mostly in the US. For the purposes of this talk. So these are sort of the cropping systems, most of the customers that we work with. This is a fabulous map by Bill Rankin, who I believe teaches here, and I love showing this map whenever I can. But just to sort of situate you about where I'm talking about, mostly we're looking at the red, which is soybeans, the green, which is wheat, and the orange, which is corn, which puts us in the Midwest mostly, so center to Midwest. And this is the kind of farming that you think of probably when you think of conventional or industrial farming. So these are huge farms, thousands of acres often, highly mechanized, very low number of operators, often family farms that have been in the family for generations, growing mostly corn, soy mixes, and commodity crops in general. All right, so let me get into the weeds of what Granular actually is. So Granular was this startup that was acquired about 2 months ago by DuPont Pioneer. We have 3 different software products, Encirca, Granular Farm Management Software, and Acre Value. For the purposes of this talk, I'm going to stick with mostly talking about our Granular Farm Management Software and Acre Value, though happy to answer questions about Encirca later. So to start, I think Acre Value is the easiest to describe, and essentially you can think of it as a Zillow for farmland. So here we provide a comprehensive context for evaluating farmland. You can see that we have soil data up on the right, your left, and we provide property boundaries, among other things. So the sort of stuff we're pulling together are things like growing degree days, precipitation, and soil quality, right? So these are just a few of the layers, but we're overlaying tons of both public and private information to try to build up this context. So using this, we also have historical sales. So you can look around the nationwide and see what farmland is selling for in your area. And this is, we find, to be consistently useful for both people that are interested in selling their land or those that are interested in buying and understanding the comparable sales, much like you would use Zillow. Though the number of farmland sales are sparse. So if we compare the sales in Des Moines to what is agricultural sales in the state of Iowa over the same time period, residential sales in Des Moines alone are like 3 times what we see in Iowa. So these things are sparse, right? We're not dealing with MLS listings where we get millions of transactions all the time. And so this is tough for you to see maybe comparable sales in a comparable time period in your region. So data science, in this case, we spend time trying to predict this sale price, right? To provide valuations at a parcel level so that you can surf around and understand, at least for a starting point, how much this farmland should be worth. And this model is essentially fit. Given we have historical sales, we take all of these different environmental covariates and build models. There are challenges. So as I mentioned, data is sparse, it's also noisy. So in particular, this is sort of like a sketch of what I actually see in the distribution when I look at Iowa farmland. We can see that there is a mode around, and these are also all missing an extra 0. So a mode, like somewhere between $5,000, $6,000, but we also see this peak right around 0. And also super high value, right? And these we can know from context are probably not real. So some of the problems we have is reliably identifying third-party sales. Farmland is very local transactions for the most part, and so we can often determine based on names whether or not it's a third-party transaction, but plenty of times these are long-term relationships that we have no context for. So when we see farmland selling for way under value, that's often the case. So that's a challenge. The other challenge is that sometimes farmland goes for way more than you should expect, right? So more than $20,000 an acre. The most valuable piece of farmland that sold in Iowa was $21,000, and that made the news. So to see like 20 sales like that in 6 months seems unlikely. And this is often the case of smaller parcels that are residential and selling for the property of recreation. So these are both challenges that we deal with. Another thing that we don't have, to just rack up the challenges we have, accounting for farm infrastructure. So in this case, if you have grain bins, if you put in tiling or irrigation, these pieces that will increase the value of the farm, we don't have data on that at this point. So we can also undervalue for those reasons. That said, there are plenty of ways to deal with this. There's very well-published statistics about dollar per soil productivity point. So we can add filters like that to sort of drop the data that we don't expect to be real agricultural value and improve some of these data sets. The other thing that we do to try to deal with this noisy data is that we use machine learning and regressions. So we're using right now gradient boosted machine models, which are machine learning regression, though we've tried plenty of other ones. These broadly, without going into too much of the guts, use decision trees as the basis, and they combine many weak estimators and can handle a bunch of different covariates, right, and are very robust to correlated data. The cons, of course, for anyone who's got any experience with this, is that they can be totally black boxes. Not quite so bad as this XKCD comic would suggest, but still can absolutely be black boxes, and you have to be very careful that you're not overfitting them to your training sets. That said, there's plenty of ways sort of diagnostically to examine these models. One of the most common ways is understanding the variable importance. This is not unlike looking at coefficient strength in more typical statistical models. So we can see that this matches some of our expectations. Soil consistently comes out, and soil quality measures of those consistently come out as the most important when we value farmland. The year, the timing of these sales matter, as does the total parcel, crop cover, so whether or not it was in corn, whether or not it's pasture, something about corn prices, in this case that's a basis, livestock demand for corn, and rain. So these sort of make sense as being important predictors. So with all of this, we can then make these lovely maps. This is the state of Iowa. Every parcel is valued based on its land value. And we can see some patterns that we would expect. So for example, we know Northwest Iowa has the most valuable farmland. And indeed, you see in the top corner that has dark is more valuable, light is less valuable. You see some of the most valuable farmland in that region. Similarly, you can see rings around Des Moines and some of the other cities, which we also find that increasing population density improves value of farmland. We also know that the southeast of the state tends to be lower quality farmland, both because soil quality, but also interestingly, the field shapes are not as square. And the field shape is a big deal, especially when you're dealing with commodity crops, right? You're dealing with huge machines, and it's much more expensive to hit those contours than it is to just go straight up and down. So this actually really shows up both in our model and in these predictions. So we've got a lot of things. We're a pretty small team, and we're now ramping up with our acquisition. We have a lot more capital to work with, so we've got a lot on our plates. Right now, we're only in four states in which we have valuation models. So that's Indiana, Illinois, Minnesota, Iowa. We'll be expanding to Ohio and Wisconsin. We also have Michigan, Nebraska, so we're sort of expanding in concentric circles with the goal to have complete nationwide coverage. There's some super fun challenges modeling-wise that comes with that. Water value, super important as you move west. So just because your soil's good doesn't mean that you necessarily have the water to grow the crops you want. So that's an exciting challenge. The other thing is obviously right now we're pretty in a corn-soy dominated system. So understanding what variables drive value, for example, in almonds are unlikely to be the same as corn and soy. So like squareness of fields, probably not as important for almonds. Other things, we're adding new layers, both for customers that use acre value, so adding additional topography, flood maps. Wind speeds, crops can often be damaged by wind at certain crucial times of the year, so being able to offer that sort of wind stress, and some measures of aridity. And then all of this will indeed improve our model accuracy by providing new covariates, but we're adding some more sale data. We're working on image classification to detect infrastructure, so whether it's irrigation or grain bins, with some great high-resolution satellite data that we're starting to get. We also have information on assessed value that we have yet to pull in, and property taxes and some other measures of field complexity. Okay, so that was a whirlwind through acre value and some of the data science there. To talk about granular, in this case, so I think a few things that are relevant to talk about for farmland. This is a map that shows the change in farmland over time between 2007 and 2012. Blue dots represent farm increases, red dots represent farm decreases. in general, you will see many more red dots than blue dots. And some of those blue dots, especially in Indiana, are actually due to Amish communities. So we're not seeing, so Amish communities are indeed growing, but most of the farms are not due to other, I guess, what's plains folk, farms that are being created. So we're mostly losing farms. A few other relevant facts to set the context for you all. The median age of American farmers is 58, and it's been increasing over time. And this means, in general, we are not getting as many young farmers as we are losing old farmers. So in general, the cohort is aging. The farms that are remaining, so we're losing farms, those farms that remain are growing in acres, right? So we're not getting any new farmers to take up those old acres, and the farms that are remaining are using them. And with that, farmers are increasingly renting land, and renting land from non-farmers, right? So this is sort of the context we have in the US, especially in the Midwest. And this generational change, this sort of farmers, small farms, 400 acres or so, are retiring, giving their land to their kids. Kids are not farming, and they're renting it, means that you have increasingly complex farms that are looking to become more professional. And this is sort of the genesis of Granular's farm management software. So this is business software for farms. So this has both got a mobile app and a desktop interface. And it's working mostly to bring everyone together on the same page for the operation of these complex businesses. So operators in the field, people that are running the equipment, and the people in the office understanding the operations that are happening across sometimes these hugely disparate farms and fields. And then the other goal is to be able to calculate profitability on every single piece of field, right? So exactly how much you spent on your inputs, how much you yielded, to be able to slice either by field or by crop or any combination. So some of the things that we're able to pull in here are machine data. So a lot of these huge combines are all like, Internet of Things, smart enabled. So they're taking data at a meter by meter resolution, right? Whether it's seeds they're putting down, fertilizer they're putting down, how much they're yielding. So we get that automatically directly into our software. There's a mobile app, as I mentioned. So this is really useful for operators as they're in the field. They're able to both log the work that they did to track their hours, exactly what their application rates were. So you might plan a certain application rate, but then you end up applying more or less. And of course, log pictures and stuff like that. So it's a tremendous amount of data that we're able to collect here. This is maybe the most exciting for those of us that are ecologists or other environmental scientists. We get input application and timing, right? So this is an example of what you might see, right? You have the date that things were completed, what was put down. So in this case, it was lime, it was potash, the rate at which they were put down, and how much that cost per acre, right? So we get that both for the fertilizers. We also see the seed that was planted, fertilizer that went along with that, whether or not they sprayed anything, what they sprayed, and then additional fertilizer. You would also see harvests in this view, things like that. So this sort of gives you that comprehensive field level view, like both environmentally, but also economically. So with this, right, we can actually give them real-time financials throughout the season, both combining their planned tasks for how much the planned work that they've got will cost, and then feeding in actuals as they happen. So this is an example of comparing on a hypothetical farm, corn, both production revenue, input costs, so that's fertilizer, seed, chemicals, land costs, that's for if you're renting your land, operating costs for running your machinery, gives you contribution margin, and then you can also have obviously fixed costs, anything that's uniform across the operation to get profit. In this case, this farm, hypothetical farm, lost money on corn, but made money on soy. And this is the kind of information and insight we're able to provide our growers for them to make decisions about crop choice in future years. Great. This is a fabulous system of record, but there's not actually any data science yet. So what is it that I get paid for, besides just like oohing and ahhing over that data? So yield and price assumptions drive huge decisions on the farm. Yield variability, especially in these operations, can vary hugely and can easily be the difference between profit and loss. So just to sort of drill this in about why we care about yield estimates and how data science is useful here. So if you think about revenue, you need to have an estimate of yield, and you need to have an estimate of price. Because these are commodities, there's lots of uncertainty about price, or there's some uncertainty about price, and that's non-trivial, though I won't discuss it now. I'll just talk about the environmental variability with yield, but I do acknowledge that it exists, Eli. And so the first question that this can help you understand is how much grain will you actually have, right? Like how much should you sell? You don't want to contract grain that you don't have. If you add direct costs in there, you can get your contribution margin, right? So if you add seed, chemical, fertilizer. you can start to understand how much should I be paying for rent, right? So is this field actually worth this to me? Am I going to be able to get a return? And I can start to understand which crops are the most profitable. If you add indirect costs, you can start to get net profit, and you can understand what price do you need to see for your crops in order to break even, right? So yield is fundamentally, assumptions about your yield feed into all of these decisions. So if you overestimate your yield, for example, you may oversell 1,000 bushels of corn, about 5,000 acres worth of corn. You could overpay by $80 an acre, which is easily the difference if you have a margin between $20 and $100 an acre of losing you money. You can overestimate your corn benefit by $80 an acre, and you can underestimate your break-even cost, right? So understanding the variability or uncertainty around your yield estimates is crucial for you making robust decisions on your farm. This is tough. This is what we hear from customers when we talk to them about how did they think about their yields. They go with their gut. They're very unscientific. Some of them feel like management has changed so much that they can't even use data that's older than 5 years old. And some people, have at least thought about it, and whether or not it's perfect, they have a consistent way of estimating it, which is an Olympic average. So our goal here was, can we make it easier to get a better number, right? So this would be a huge source of uncertainty that we could help our farmers with. So what this looks like for us is we want to be specific for every farm and for every field. We want to start with their data when we have it. We want to pull public data when we don't have it. And we want to make sure that we're using the power of the historical data when present. So what we're trying to do is not do in-season predictions, right? We're not trying to say, in May, what is your yield going to be in September? We want to say, on average, in general, how much can you reasonably estimate this field can yield for you? So we're not trying to estimate, the 2012 drought. That's not what the goal is at this point. And we also want to be able to reflect changes in management over time, and we want to automate it, right? So that we can rinse and repeat this for any field, any farm, any crop. So that's the goal. I'm just going to talk about one very small part of it, unfortunately, which is just the public data portion of how we might model yields as a function of public data. So when we think about the public data yield model, what we start with automatically is soil quality, right? So soil is one of the most important predictors of yield, especially when we try to think in these long-term general averages, right? So we're not trying to do year-to-year variability, but in general, what controls yield year after year, and that's soil. You may ask, hasn't this been done before? And it has. There are a few indices for soil quality that exist. The National Commodity Crop Productivity Index, that I will refer to over and over again as NCCPI, exists nationwide. And the Corn Suitability Rating, CSR, and CSR2, which is the next version of it, that exists, for example, in Iowa and is pretty well respected there. Various other states have their own soil ratings. Illinois has PI, Minnesota has CPI, Nebraska has one, California has one. Each one of these is state specific, and also, so they're not able to be used nationally. The other problem with these is it's really difficult to tell what goes into them. And if anyone has better information than what I'm about to share, I would be thrilled to learn about it and be proven wrong. But there's also no measures of accuracy, and there's often been suggestions there's a lot of spatial autocorrelation. So when I read the methodology of these things, they're often start by being a combination of crisp and fuzzy logic and with an addition of expert knowledge thrown in. And as a data scientist who may be savvy with data and have some experience on farms, I don't have the expert knowledge in Iowa to be able to say that is 120 bushels worth of acre worth of corn. So what I was seeking to do is be able to both benchmark their accuracy and then see if I could improve on that. So this goal, again, is just to predict average corn yield in general as a function of soil characteristics. All right, so the methods. Bunch of different data sets that come in here. Let's just start. This side is the yield. So this is what we're trying to predict. So I'm using yield data from USDA. They take a survey every year at the county level and say how much corn did you grow, right? So that's an average yield per county. I take that starting in 1995 and go through 2015. So that's 20 years worth of data, and I take an average of that because I'm trying to do long-term yields. I'm not trying to catch that year-to-year variability, and I detrend, right? So if you look at, it's a pretty fun data set for those of you that are not familiar, NAS Quick Stats, highly recommend. You can plot corn yields over time, and you can just see the exponential, not exponential, but you can see this huge increase in soil, in corn, and that comes from both practices and seed genetics over time. So I don't want to be capturing that, so I detrend for that. I also add in irrigation data that's also available from NASS. What I want to do is I want to find places that are growing corn using rain-fed agriculture. If you irrigate, that means that we're looking at the value of water, not the value of soil, right? So one of the main qualities of soil for crops is its ability to hold and store water throughout the season. So I want to be able to capture that and make sure that I'm not dealing with an irrigated county. So anything that's fewer than 20% irrigated is what I use. All of that comes together. So that's the response side. We're looking at the predictors. I'm doing a couple of things. So Surgo is the NRCS's database for soil that covers the entire United States. It's got tons of attributes: clay content, depth to bedrock, water holding capacity, organic matter, conductivity, pH, all of these things that we think are important for soil quality. So we get all of that attribute data. Because I'm going at the county level, I don't want to be using soil data in those counties that wasn't actually used to grow corn, right? So it would be sort of silly to say the mountains of Arkansas, what is their soil? How does that relate to county yields? Because obviously those things are not talking to each other. So I use what's called Cropscape, which is a 30-meter raster provided by the USDA that details crop cover for every year. So I overlay that with the soil data so I can get just the soil in places that are growing corn. With that in hand, I cheat a little bit and use one measure of climate, even though I told you I was just doing soil, and that is a measure of aridity, which is the vapor pressure deficit, and that's the difference between how much moisture is in the air versus how much moisture could totally be in that air. Let's see, total amount of moisture that's presently in the air versus what it would be if it was saturated, right? So the higher the VPD max, the higher the VPD, the more arid it is. The lower it is, the more humid it is, right? And so crops tend to grow better in more humid environments because there's more water for them available. So all of that, I'm going to ignore some of this jargon, but I'm aggregating that soil quality to county level. So now you have a data set where you have county average yields and county average soil characteristics. I do two things. I make some baseline models. Where I actually try to say these indexes, how do they correlate with average yields? And then I build a new model to see if I can do better than them. So just quickly, this is sort of what data availability looks like across the US once you've done all of this munging and adding of data together. Red is where I've got everything that I need. Some places you don't have corn yields, fine. Other places you don't have any information about irrigation. Some places we don't have the other indexes present. So I'm pretty restricted to where we see most of the corn grown, which is the Midwest, which makes some sense. But just to note that I am not able to do this totally nationally just because of lack of data at the public level. Okay, so just briefly talking about baseline models, what I found. So here I'm plotting NCCPI, that's the average, county average national commodity crop productivity index. You can see that it's, and then on the y-axis is the county average bushels per acre. You can see it's positively correlated, which is good. Though accuracy is middling, I would say. The points here are sized by the area in corn, so I weighted this regression to try to better fit it to the counties that are growing the most corn. The new yield model, so I use that county average characteristics to the soil data by Surgo plus Prism. I fit another GBM, though that is less important, it turns out, to the accuracy, to 80% of this data. And then I'm predicting the detrended county average. I'm weighting each county by the acreage in corn. And then I bootstrap this model a number of times, right, to make sure that the accuracy I'm calculating on that held out 20% is representative, right? So it didn't just get lucky and hit on a great 20% to test the data on. So the results are improved accuracy for sure. So you can see in R squared, we're up at 0.85 as compared to 0.68. So in general, this improves our ability to, and then our average error is around 10 bushels an acre. So it's pretty good. Again, you can interrogate this model, much like the AVM. So we can see this is still in Surgo jargon, so the covariates are going to be annoying to look at. But the most important is that vapor pressure differential. So that aridity we had reason to believe would be very valuable is indeed very important for predicting corn yields across the US. The next step is water holding capacity. I believe that salinity is the next thing. Water holding capacity, another measure, organic carbon, conductivity, and it goes on. This data set is actually like 141 different covariates. So there's also work that I've done to try to reduce to the most important covariates and dropping some of the ones that are correlated or have weak predictive ability. But so we can see that makes some sense for us. We can look at individual covariates and how the functional responses of our response variable vary. right? So how are these related? Just as a sort of ecological sanity check. So looking at the vapor pressure differential, we can see that as aridity increases, we see a drop in yields. This is what we would expect. This is water holding capacity. You see a sigmoidal function. So as water holding capacity increases, we see some increase in yield, though you'll note that the y-axes are not the same here. So the increase is much more minor than when you see changes in aridity. Similarly, in soil organic carbon, I'm sorry about that x-axis, you see a saturating curve, where as you increase soil carbon, it matters, and then it stops to it doesn't matter quite so much. With this model, then I'm able to certainly predict back to the counties at a county level, and this is a prediction of corn yields across the country at that level, which is great. You can also, though, downcast this, right? So this is Pocahontas County, Iowa. Iowa is great with square things. And so each of these finer scale Sergo shapes have all of the attributes I need for my model, and so I can downscale. And that will let me predict yield at a field level. All right. So let me move on to some of the work that we're trying to do to support sustainable agriculture. So this is probably not a necessary slide for those folks here, but just it matters a lot, right? Agriculture is a huge contributor to habitat conversion. Fresh water use is a really big deal in terms of losing topsoil and erosion and greenhouse gas emissions. Agriculture is a huge contributor globally. So anything that we can do to change agricultural practices and start to capture some of those externalities associated with this practice, whether either the public's paying for it or the farmers are paying for it, is, I think, hugely helpful when we think about natural resource management. So as the sustainable agricultural landscape in the US, as I see it, when I look at our customers in particular, so remember this is sort of commodity corn and soy growers, big professional farms. I think that there is absolutely a push for environmentally sustainable agriculture. Certainly, at least some of us want to buy it. Those of us that have money to do so, there's a market for it. If you look at Whole Foods, there's also increasing public concern for greenhouse gas emissions, and this often brings fertilizer use to the front. Right, so Walmart has made some big claims they're very excited about to reduce their greenhouse gas emissions. Looking at their supply chains, they realize fertilizer use is a huge contributor to that, and so even if they weren't already interested in agriculture, that becomes a huge target for them to try to address down their supply chain. And I see a lot of NGOs stepping up to help and assist with these efforts. The Environmental Defense Fund and the Nature Conservancy have both announced partnerships both with Walmart or General Mills, some of these other big growers or other big retailers, to help them try to meet the goals that they've set for themselves. For what I see in terms of existing programs, we see two in particular: Field to Market, which is this big tent initiative that involves both people like EDF and the Nature Conservancy, big ag retailers like now us, DuPont Pioneer, Dow, Monsanto, Syngenta, plus a number of grower associations. The Corn and Soybean Row Crop Association, among others, are all a part of this huge tent initiative. And that's mostly about trying to benchmark and commit to continuous improvement. The Sustainability Consortium is another one, and that's mostly focused on specialty crops. So between the two, they tend to try to cover that. And both of these really, as far as I can tell, have come from Walmart saying, I want to be sustainable, right? And I want to be able to quantify how sustainable I am. And they went to all of their growers and said, all right, so how sustainable are we? And everyone was like, I don't know, I don't have the data. So a bunch of money came from the Walton Family Fund to try to support these initiatives. But again, this has principally been started for processors and actors that are further upstream, right? That these are not built with the grower in mind, but the grower is part of it because they have to be, since that's where a lot of the emissions are happening. So certainly, perhaps you've already guessed, Granular really easily feeds information into these partners, right? This is the kind of information that you want to be able to aggregate to know what the practices are at the field level. Right, this gives you the amount of nitrogen that you applied per acre of your field. Right, this gives you the herbicides that were used or not used. This also tells you whether or not you did cover crop or whether or not you did no-till. All that information is available just by default because we capture everything in their operations. So we're super excited. Both the Field to Market and the Sustainability Consortium are still sort of slow-moving beasts because they are such big tent initiatives. Eventually they'll have APIs in which we can easily feed our data to them, and we're super excited to be partners in that and looking forward to being able to share that data upstream as both our farmers requested of us and as it's required of them to help them meet whatever certification standards they need. This is what I was mentioning, so this is an example of the sorts of things that we can do. We can do these really simple plots of nitrogen versus yields, right? This is one common way to understand nutrient pollution, is to calculate your nitrogen use efficiency or your phosphorus use efficiency. So how much are you exporting off your fields? How much nitrogen in the corn are you losing? And how much did you put down? Presumably, whatever's left is stuff that can go into the watershed. So what you're trying to do is get as little left on the field as possible for contribution downstream. So we can make this calculation pretty easily with what data we have. And like I said, tillage practices and cover crop use. The really exciting thing is that we can also contribute new tools. So we're at a new place, I think, both with acre value and the combination of farm management, to be able to start offering, instead of just existing supply chain initiatives, additional grower-centric tools. So going back to this facts about US farms, this point of farmers are increasingly renting land from non-farmers. We see a number of questions about sustainability, but in particular, landowners want to know, can you tell me how sustainably my tenant is farming? And can you define that for me? So these are questions that farmland owners have that have no way of answering at this point. So I think that we are now in a great place to be able to quantify the sustainable practices that these growers are engaged in, and using acre value, we can target the rental markets, right? So we can say, this is how sustainably this farmer is farming, and let them market themselves on that, which might give them access to farmland they didn't have previously, or reduce rental rates for the things that they're paying, which is super important, as land value is the most expensive thing on any profit and loss sheet you look at for our customers. So I think that this will just further align incentives, both leading to wins for both the landowner and the farmers. The content of this is still to be worked out. This is very much planning stages. But in general, we're sort of following the tenets of conservation agriculture, right? So looking at tillage practices to reduce impact to soil, try to make sure that it's covered so you get less nitrogen runoff, and make sure that you're doing a diverse mix of crops. I think that in general that this index will contain two different parts to it. One will be content, so this is about practices, so cover crop, tillage, et cetera. The other part will be certainty. So certainly anyone could opt in and report whatever practices they would like. So that anyone can use it. But obviously, I could say whatever I wanted on those forms. So there'll be tie-ins ideally with our farm management software and other clients where you can pull their practice information automatically, right? And be able to infer with a higher degree of certainty that they're unlikely to be lying about the way that they're practicing and farming on those fields. We also have plans to allow landowners to be able to see into the farm management software if the farmers want that. So they can opt into that, so farmers can actually have a window into the operations day to day to have increased confidence the way that their farm is being run is sustainable. So you can think of multiple different ways. So one will be content, one will be certainty. And of course, we're not the first people to have thought of this. So this is put out by the Nature Conservancy. They recently announced an initiative to focus in North America on soil quality in particular. And one of their steps in this long chain of things is to align incentives between landowners and farmers. So they're already doing experiments in which they are offering assistance to rewrite leases that have more sustainable practices in them, and seeing whether or not landowners are more likely to use them, or offering payments to landowners in order to require this. So it's exciting to be able to offer these tools to farmers that are also in line with sort of the broader societal goals that are happening around agriculture. So I ran through that like really fast, and I think we have some time for questions. Oh wait, I have some next steps. So a big part of this is you manage what you measure. So being careful about what practices we choose to include. We don't want to reinvent the wheel, but we do want to make sure that these are, as an ecologist, like actually meaningful metrics that will actually drive meaningful change to reward farmers for good work. We're also doing some work on satellite detection of practices, so being able to detect cover crops, for example, so that we don't even require necessarily farmers to report that, but we can have some guess already whether or not we think that those are being followed. We also need to do some work on our own product to make this even better. We need to be able to let users claim properties, for example, so that they can say that this is their farmland, or say that this is where they're farming. So stay tuned on all of that. And with that, I would be happy to take any questions.
Thanks, Emma. In this semester in my data science class, we've talked a lot about data and expertise moving out of the academy into the private sector. You think about Google and Amazon, but maybe even this. I was wondering if you could talk a little bit about that, kind of your thoughts on that, your experiences but also, like, are these data available? Are, I guess, what's the kind of end goal? Is it for like the common good? Is it to make money? I'm not saying it shouldn't be, but kind of, yeah, speak to that. But also, I think on the flip side, we've talked a lot about the quality of the work in the private sector being maybe even as good or better than in the academy, just because of all sorts of different constraints. So that too.
Yeah. Okay. So three parts: academics moving out of the academy, public good versus private good, and data availability and quality of work. Okay. So as someone who did my PhD in a very academic institution and then left, I think that my experience was that I had no idea that these kinds of jobs existed. And that may be just unique about Princeton's program in general, that it's very narrowly focused on academics, but this was a total chance for me to meet. I had a friend, a postdoc in my lab, knew the co-founder of Acre Value and was like, oh, you should talk to that guy. You're into farming, you're into quantitative stuff. And so the Skype call was literally, am I a data scientist? Oh, I am a data scientist. Oh, you do cool work. Oh, you're hiring. And so that was like a totally fortuitous event. And in talking with students while visiting here, I feel really badly being able to share, like, that's my advice, like randomly have a great connection. So there's some really well-known opportunities to do data science, but this sort of more meaningful, exciting interface where I'm certainly working for a for-profit company, but I'm doing stuff that I think is profoundly interesting, right? I'm learning how the food system works. I get to talk to farmers and think about how they make decisions. There's no systematic way to find this. And so if you're having trouble finding it, it's because it's hard. And so I think that increasingly there's great opportunities for, especially for anyone who can program, but especially I think PhD students are well situated to this because we do independent work on our own and are able to then take programs of study and implement them in these industries. So I think we're really well trained for this, but it's not on purpose that we are. So that's the first part. Second part is public versus private good. I was drawn to Granular because I did my work in fisheries. I used NOAA data to look at how fishermen searched across space on the West Coast. I was really excited to use NOAA data because I was using the data that management used, right? So any products that I did would automatically be at the right scale. I didn't have to like figure out how to map their data to my data, whatever. I got done with that PhD, and besides finding it much harder than I thought, which is like the story of all PhDs ever, is that my products required at least 2 or 3 more papers before I would even want to advocate for them being used in the management context, right? Like they were really compelling, interesting, sort of whole ecosystem ways to think about how fisheries are connected to one another, but I don't actually know if they're real, right? Like, so I was able to pull all this interesting data together, but I'd want to look at, the crab fishery closed out there. I would want to know whether or not I was able to predict how fishermen would switch fisheries. So I was a little bit dismayed at how slow things were. Whereas here at Granular, all of a sudden, I get to help farmers make decisions to make their operations more efficient on a day-to-day. And so I see my products going into implementation fast, like within 6 months, which is super exciting. And like the idea of being able to work on a sustainability index or to align incentives, like I have talked a great game about that for a long time, and now being like, okay, why don't you go do it? Like, holy cow. That's really exciting and terrifying. So in a way that I never experienced in academia, even working directly with NOAA scientists in the system, talking with managers, talking with fishermen, I would no way have this kind of ability to implement. In terms of the technical expertise and the quality of work, yeah, so most of my colleagues are ex-academics. I think almost all of us have PhDs who decided we don't want to write grants and we don't want to apply for tenure. And so I've been really impressed with our quality, and because so many of us come from this sort of self-teaching background, we're able to stay on top of things and actively work to keep each other up to date. And so I found there's also, even though it's for-profit and we want to get things out, you don't want to be wrong, right? There's a huge commercial problem if you lose your respect, and so there's strong constraints on pushing things out that are shoddy. I would say certainly if you could tell from some of this work, we can check and verify these machine learning models, right? And say, okay, soil is most important, and this is roughly corresponding to our expectations. We're not rigorously understanding the mechanisms that are driving these things. So that would be the trade-off, and that's sort of a gray space that varies, I think, from company to company. Public versus private good. So I joined Granular with the idea that I could maybe be, this is me speaking, sort of an ecologist or someone who's interested in natural resource management and be a little bit behind industry lines to be able to identify these places that really farmers could benefit and that also are meaningful public goods. So I found this particularly compelling, and that's why I immediately leaped out of academia for it, was because I thought this was a unique intersection between those two things. That's not always true. Data scientists are a lot of them are looking at advertising. How do I show you the most important advertisement when you click it, right? And that's fun data, it's huge, lots of interesting signals, but I find that profoundly uninteresting. So there's tons of places to get paid to do that, but I think a lot of this work is compelling precisely because it's at that intersection in an exciting way. Yeah.
Very implied one. There was maybe you went through too fast through some parts of it. So I have questions to the time scale of these predictions.
Yep.
So if the farmers want to know what happens in 5 to 10 years, for instance, can you do these predictions? Or I mean, in 10 years you may have some changes in climate. I mean, many things can happen.
Yeah.
Are you able to do these predictions, or your model relies on some assumptions that don't allow to do predictions beyond, I don't know, 1 to 2 years?
Are you thinking about the yield model or the land value model? Both.
I mean, both, actually.
yeah.
I mean, yeah.
Yeah, so I would say this sort of goes back to sort of the technical mechanism versus sort of just phenomena prediction. The yield model, well, the valuation model for sure is a much stronger snapshot in the current time than it is long term, and that's mostly because the training data that we have are only over the last 5 years, right? So we don't have extensive time series to be able to fully feel like we would be able to predict into the future. The other part of this is that we're not actually modeling any of the mechanism, right, about how the land market works. So if novel things happen or things happen in the system that we don't have data on, we're unable to predict that. So I would not trust our predictions, 5 years in the future, because so much may change. The farm bill will change things. Crop insurance may change. So the underlying sort of system may shift into a new space that we don't have data on. So in that sense, that's the drawback of this very data-driven approach, that it will be a little bit lagging, right? We'll have to observe that phenomena before we can start to incorporate it into our model. So that's the first part. The second part for yields, the public data, so the public approach, I think is pretty good, though certainly long time scales when we start to deal with climate change, we're going to see shifts in aridity, which will drive changes in this model. But the kind of data that we provide, as long as we're using climate, we could use climate simulations to try to understand where yields are going to shift to. The other thing that changes a lot, though, are seed genetics over time. And so developments there 10 years out make it tough to, I'm basically saying it's tough to do it more than 10 years out, I think, just because of the dynamic nature of the industry. Certainly when we start to deal with we also have historical yields for farms, for many of our customers at individual fields. That provides a much better estimate of yields in general. And again, I think is much more accurate, but again, I think it runs into the same changes like management. Like if they decide to grow a different crop, I can predict corn all I want, but if they're not growing corn, it won't matter. So that's sort of, as you run into 5 to 10 year, 15 year timescales, you start to worry about those sorts of changes of systems. That makes it difficult. Yeah.
Thank you.
So you mentioned that you manage what you can measure, and you don't want to be wrong.
Yeah.
So I'm wondering, how often do you lie awake at night worrying that maybe there's a variable, say in the yield model, that varies within a county, and it has a really strong effect on yield, but when you aggregate to the county level, you're going to miss it, and there's no variable importance. And clearly you can get at that with the private data you're getting, but
Yeah.
I'm just wondering whether or not you think that's a major constraint.
I think it is a major constraint, and certainly we don't use this yield model alone and don't push it as like, we know what's up with your yields. In fact, most of the yields that I predict at a county level are 50 bushels an acre less than what we see in many of our customers. So I think this is for sure an underestimate, and it's mostly useful to sort of anchor any sort of relative differences across large spaces rather than using it. The nice thing about having that private data is that we can actually start to get an estimate of error at that scale. And I'm embarrassed to say before this talk that I have not yet done that, but I have all the data in place to do it, so it would have been great to be able to show you exactly what that accuracy is. So the goal certainly is for this to be a helper, but not a replacement for any kind of fine scale data. And like soil tests also will help with this as we get more of those in our database too, to be able to use actual soil data that's present, not inferred from the rest of the county. Yeah.
Do you have any evidence? Oh, sorry. Do you have any evidence based on, I know you guys have only been around for a while, but part of the kind of intention of Granular and similar efforts within the ag economy, or to try and give farmers better information such that they can kind of more fine-tune their decisions, and perhaps maybe that's more sustainable, more profitable, everything like that. Do you find with your client farmers, are they actually beginning to do that? Because there's a lot of other kind of behavioral research, rural sociology research that farmers can be really difficult to change behavior in because they're so risk averse, and farms are really difficult businesses to run.
Yeah, it's a great question. Yes, we have a few anecdotal examples of working with farms in sort of one-off ways to help them understand their data, where we see changes in which granular information drove change. And that is super valuable for us and also for our sales guys to be able to point to it and say, we're able to actually save you money, because that's like our whole value proposition. So, and those cases are typically, so one example was a farmer who farms potatoes looking at different varieties and based on maturation rates and quality. And so he thought that by putting in a potato that would mature quite quickly, he could use empty field space. But it turned out the amount of inputs it cost him to grow that potato didn't actually make economic sense. So he was losing money even though he was making better use of the field, like having the field more full. So that was an example of intuition where he would have thought, well, in general, like just having more crops is going to yield me more outcome. We were able to show specifically that he was like throwing money away by doing that. And so he is not doing it this year. So we have a number of those like very targeted examples. And I think this sort of speaks to a broader thing that I see with granular, and a similarity with fisheries is that fisheries are also a place where fishermen and managers come head to head about the way they should be fishing or the way the system works, right? And I think that's sometimes at root when farmers say they don't want to change because they don't believe extensions, they don't believe the advisor that they really understand. Both of these are systems that both farmers and fishermen have great internal heuristics of the way the system works because their livelihoods depend on it. Whether or not it's perfect, it's not optimized, it satisfies to like make them make money or at least stay in business. So fishermen sample the ocean in a very different way than survey managers do, right? They do a stratified random sample and fishermen are fishing where they think the fish is. That results in really different understandings of how much fish is out there. And so if you already are disagreeing about how much fish is out there and you don't trust the other that they're being honest, right? Fishermen, of course, would think that the managers would say there's too low so they can put in regulations. Managers, of course, think that the fishermen just want to fish so they're saying it's too high. It's very difficult to have the trust to be able to talk about trade-offs and to manage cooperatively. Farmers, I think, can be similar, right? Like you don't understand what's happening on my fields. I'm here every year, every day scouting. So having farmers collect the data that they can look at, that they put in, that they trust, I think lets you be on the same footing to say, we're both looking at the same data set together. It looks like you're losing money. Tell me what you think. And that lets them be empowered to trust. And so I think that's the difference with Granular that I've loved being a part of, is being able to come at it from the grower's perspective to leverage their insight. Because a lot of times I come up and I'm like, this is losing you money. And they're like, no, let me tell you about the context. I had to get that land because it was bundled with this other really high quality land. And if you slice it that way, I'm making money. So it's those sorts of context specific things that are pretty difficult to say from the outside as a data scientist, but we're able to get at by working with them collaboratively. Which also is really exciting from a sustainability perspective, right? To be able to say these things that maybe are associated with environmentalists or whatever that you don't trust, but actually it looks like this could save you money, it reduces your risk in these ways that like, I don't want to say that unless that's true, right? Our business depends on that. And so that I think that also offers an avenue for discussions about new practices in a way that we haven't had before, which is exciting.
I have another question about the word farmer, your use of the word farmer. It seems to me that from your trends data, you seem to suggest that the big farmland is going to be owned by third-party people, maybe Walmart or maybe somebody else. And the managers of those are going to be people that actually run the automated machines and analyze data. So my first part is, are those really farmers? And then the second part is, I think you could think of farmers, and I'm wondering how Granular thinks. There's the very small farmer that's working on, I don't know what, yours. Then there's sort of the intermediate, so this gets to the idea of adopting technology. The small farmer is likely to be someone who's done it, wants to do it his or her way. The medium farmer, the next farmer up, has a slightly larger track, more into the market commodity, the national commodities market, I think maybe could be swayed. And then my question is, at the next level up, it's really not farmers anymore. It's really going to be the programmers of the big combines that are just working for the people that are renting the land to them. So I don't think there's a question there, but I just wonder how you see the word farmer in the context of all this.
So I think that the trends, So it's very exciting. There's a lot of new technology being offered to farms, whether it's drone imagery, this kind of data collection, automated tractors are like a thing that are coming, especially in the US, especially for commodity cropping systems that are pretty straightforward and highly mechanized already. I think that those trends will continue. And let me be clear, I'm talking as myself, not as Granular. So let me just give you my own opinion about these things. So I think that trend seems to be inescapable for these highly mechanized systems, right? If we continue to grow these crops, we're going to continue getting efficiencies in this technology, and we're going to eventually automate the farmer out of it. I don't think it's hard, predicting the future is perilous. The amount of variability in this data that you see and the amount of understanding of these systems, we're not close to being able to offer agronomic solutions for farmers to say, I know what you should be doing, here you should do it. Certainly Granular would love, certainly I think that I, as a data scientist at Granular, would love to be able to say, I think you should grow soy instead of corn because I think it's going to make you more money, right? And to be able to understand those trade-offs. But that's like the first level of like what crops you should do, and then how do you optimize the crops at the field level. I still think that we're a number of years away from that, and farmers have some really, just like the generations of being able to observe how the soil reacts to novel environments is non-trivial. Like it's just non-trivial. But I do think that we are moving as a society in this direction of mechanizing agriculture and removing us even farther away from the land that we depend on in many ways. So I think that that's a real thing. And in terms of the small farms, like the super small farms, which is the size of my farm, which is like 15 acres, to the sort of more intermediate farms that are 100 acres, say, and wholesale to grocery stores. Talking with some of those, especially in Washington where I live, I think that these sorts of tools are not as available, right? These are, Granular in particular, is sold to really big professional farms that can afford it. And so we don't sell to 15-acre farms because 15-acre farms can't afford it. And so I think that I'm interested in whether or not we'll be able to democratize access to these sorts of platforms, because there's nothing inherently difficult about offering this to a smaller farm. What's difficult is offering them support, right? Offering like 1,000 small farms the support that we can offer one big farm. I think that also what's really interesting is where farmers get information, and this goes back to Dan's question a little bit, is that a lot of these farms are surprisingly isolated in their practice information, that even these big farms don't know what their neighbors are doing. They know what the seed retailer is telling them to do, and they have good relationships with their seed retailers, but just the sharing of planting dates and varieties is pretty limited. And I think lack of funding to extensions over time has really cut down on the ability for us to be able to influence practice information and disseminate that knowledge. So I'm excited about the ability to collect this data, anonymize it, and be able to share across farms to help them understand you can actually get cleaner water here, or you can reduce your machine costs and your carbon emissions. Like this should be possible based on what we see around you in your region. So I'm excited also about being able to offer those insights to growers, and that's again one of the reasons I've liked working for Granular, is that it's been really grower focused, right? So how do we help empower growers? How do we help farmers do a better job farming? Not how do we do it for them, not you're down, let me show you how. So I really appreciated that philosophy that we're coming at it with. Oh no. Cool. Thank you, everyone.
No, I haven't made it over there yet. How was it? Nice. That's awesome. Yeah.
Oh, cool.
Did you make me go back?
Yeah. Okay. Yeah.
Really? Jeez.
That would be fabulous.
Emma, we're going to switch because we have to teach you one.
Okay.
Sorry, we're kicking you out. That was great. Really enjoyed the talk. Hey, you taking all my stuff?
Your stuff.
My stuff.
Wait, are you about to
Damn it. Actually, can I steal that for a minute, the pointer, and give it back to you?
Just leave it up top.
Are you sure? Only because I left mine in my office yet again. Just gonna check that. I'm gonna turn that off. I walk around, so I turn it off. Thanks.
Are you about to
Yeah. Emma, this isn't yours. No. Yeah, I was gonna say Versace.
I'll take it.
Yeah, would you do it for me? It's eco-modernism. I feel like you're qualified. You can do this.
Carbon, 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 carbon. Nitrogen, nitrogen. Carbon.
Exactly. What else do you need to know in life? Nothing. There's nothing else needed. Okay. Okay, let's try that. So Eli, I'm gonna send you guys just because.
So we have a class in here now, so if you're not part of the class, if you want to be, you're welcome to stay. Otherwise,
Please continue conversations outside. Oh, come on. Displays. Good. I'm gonna call security. Yeah, I can flat a career, right? Just didn't pan out. So what do you guys think of that manifesto? So bullshit? You said anything that? Yes. So two bullshits? So we're just asking, just come in, Perry. We're asking what you thought of that manifesto. So far we've had a bullshit and a second for bullshit. Anyone else? Okay, so lots of bullshit. Anybody not? Okay. Why bullshit? We're gonna give a little kind of introductory lecture, and then we're gonna just one person just talk a little bit about the manifesto, just kind of get your reaction to it, and then just kind of give you some background to it, because I know if I was to pick up that eco-modernism manifesto and then read it without any historical context, you know, I read it through and I was like, wow, that's just really well written. It's changes that you can go through the movement, right? I always appreciate it when things keep moving and read lots of pages quickly. But if you don't know what the background or the backdrop to that is in terms of environmental solutions, then I think sometimes it's going to give you a little bit more thought. So it's good to start off with bullshit, and then I think we need to come around back at the end and decide when we still think it's bullshit. But first of all, why bullshit?